All right, so I just wanted to talk a little bit about the project in which is the random behavior. That's 5.5. So if you click on this one, it will take you to here. And so um, it says something about the fact that there are four possible directions that this random walker can actually take. You have north, east, south, or west. So under random, that means that we can use the random function, the math at random. So obviously, since there are four possible directions that you can take, then we're going to say that a quarter of those random numbers between 0 and 1, not including 1, would represent one of the directions the random walker would take. Now, it's not important to define, I should say, uh, which one is which one. You can, that is arbitrary as long as you're consistent throughout the whole process. So I can say north, right? I can increase a variable that represents the x coordinate of the position of the random walker. And remember, it says that I start at 0, 0, right? Right here. So all we care about is uh, this last position after n number of steps. So when a random number comes out, and you can do a 1 through 4, or maybe you can divide 0 through 0.25 or 0.24. So you can do it either in decimals, or you can do the conversion in which you have 1 to 4. I think students had chosen to do the 1 and 4 because it's more intuitive and easier to visualize. So take a look. X increases if you get a 1. Y increases if you get a 2. So 1 represents north, 2 represents east, and so on. So if you go south, then that means that we're going to decrease X. And if you go west, because it's the opposite direction at east, we're going to decrease Y. Now you can change these things around, it doesn't matter. So the final values will come from whatever the X and Y are, right? The final value of the X and Y. And so then you have to find I believe it's asking you to find the square distance, right? Da, 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 da. Also print. Well, they ask you to print each of the steps is taken, as you can see. And then in the end, you want the square distance. As you can see, the square distance over here is very close to the number of steps that is taken. It's a random behavior that seems to be very much having a pattern. Now, like anything in probability, if experimental probability, if you want to prove something that is theoretical, you need a good number of trials. So what we do in part A is just one trial. How do we do that? Well, first of all, I know that I'm going to have over here n number of steps. So I'm going to have a for loop, because usually for loops are the ones that we use when we have a fixed number of repetitions. You can use a while, and then you have a counter, of course. And then we have a series of if statements for each position. And then maybe I don't want it to do it that way. Maybe we want to do it something like they're all pretty much, let me see, can I go the way? Yeah, so it's easier for me to bring it back to where it was. There you go. So they're all independent, of course. I'm not sure why I had put that in in the steps, because it's not true. Now, if I wanted to write something efficient, I would say if else, because once you determine what direction is going, why are you going to check the other ones, right? After a while, that after many trials, that kind of implementation, that kind of code will actually um, take longer than if it was an efficient type of program, right? So you think about the if else. So I'm going to say right here that the if else is more efficient. And I think you can figure out why. So this represents one trial, only one trial. That means the random walker is taking just a walk of n steps. But again, like I said before, if we want to really find a theoretical probability, we need to do this experimental heuristic type of uh, program that will show you eventually that that will happen. That will be not just by accident. And as you can see, it says to have T number of trials. And that will be part B. So to me, sounds like you have another loop in here. So I will put this inside another loop. I will use also a for loop. So right here, I would say for loop, right? A for loop also for T number of trials. And inside the for loop, then I will have whatever I already did in the part A. So the trick over here is to have a variable defined outside one of these two for loops, and I want you to think about that, that keeps tracks of the values so you can find in the end of the distances, square distances. So in the end, you find the mean square distance or the average of the T trials square distances. I hope this helps. I think that's probably uh, the big idea. And now you have to take care of the little details. Make it efficient, okay? Use the if else. And that will make it look like a really good program. Okay? See you. If you need more help, shoot me an email.